Hi everyone, good morning. Welcome to another day of Advent of Code 2020. Glad to have you here. Hi Chris. Uh, if you're here, say hello. Let me know how you got here and let me know that you're watching. I'm excited for today's challenge. I didn't stream this weekend, so there's no. I didn't stream days 5 and 6. So before we go on to day 7 today, I'll just do a quick recap of both days in the weekend of Saturday and Sunday to show you what the puzzle of that day was and how I came up with the solution. And I'll do that really quickly before going on to day 7. So day 5 was about boarding the airplane. Our challenge was to find for part 1 we got an input that looked like this, and each row was the instructions how to for a person to get to that seat, the boarding pass instructions basically. And there were 128 rows in the airplane, and F meant front and B back, so you had to kind of look like a binary search. You got a length, so 128 rows in this case, and then each time you would half that range, and then it would say keep the first half or keep the second half, until you eventually your range is that small that you only have one row left. So that was the assigned row for that boarding pass. The first 7 characters were instructions for the row, and the last 3 were the instructions for the column. And the plane was 8 seats wide, and dividing it the range of 8 3 times, you would end up with one column eventually. So then you got your row and your column. And so giving this input, you had to calculate the seat IDs of each boarding pass. And the seat ID was basically the row multiplied by 8 plus the column of that seat. So what I did, my approach to solving this day 5 was what I did. I of course read the input, and I made a helper function here, but I'll explain this in a bit when we call it. I split the input by new lines, so that gave me an array of boarding pass instructions, and I then mapped each element in that array to be the seat ID. So basically what I was doing is I transform every boarding pass instructions to the seat ID of that seat. So what I had to do is I first, so the boarding pass instructions, that's a string of 9 characters. I split that into 2. The first 7 were the row instructions, and the second part, the last 3 were the column instructions. And then here's where I calculate the row number, and here's where I calculate the column number. And these two are basically the same, except that what I'm doing is I'm doing a reduce. So here in this case I have a string of 7 characters, and I want to reduce this to get me the row number to one number actually. And I'm starting the reduce with an array, and which is the range, or at the lower bound and the upper bound of that range. Since we're indexing from 0, it's 0 to 127, 128 rows. And here, same thing, 0 to 7, which is 8 columns. And then for each instruction, I call this helper function, get new range. And what this function does is it takes the range as an input, and the range is an array with the lower bound and upper bound as elements. And then it takes the second parameter is, do we want to keep the first half or not? Or if this is false, then we want to keep the second half, not the first one. So that's what I'm saying here. If row instruction is equal to F, which is the first half, then true, otherwise false. And the same for the column. If we go left, then we want to keep the first half. If it's right, then we don't. and it's the range is here, lower and upper bound, and then I'm calculating a new range basically, and by calculating the newer and upper bounds based on whether we want to keep the first half or not. So if we have, for example, the first range 0 to 137, do we want to keep the first half? If yes, then we in here, then we want to smaller the upper bound. If you want to discard the first half, if we want to keep the second one, then we want to make the lower bound higher. So that's what the condition here does. And then we calculate the new bounds by just subtracting the upper bound from the lower bound, which is gives us the difference between the two, or the uh, range length. We divide it by half, and then we round up, and then we add the lower bound to the new amount, or we subtract the upper bound from that. So then the range keeps getting narrower, and then we return the new range. So that's basically what we're doing. With each step through the boarding pass instructions, we shorten the range until we end up with one value. In this case, that value is going to be the row number and a column number, and then we calculate the seed ID just like the puzzle said. Multiply the row column by 8 and add the column number. So we have the row number and the column number in here. And yeah, the question was, what was the max seed ID? I got for my input 874, and that was very easy. Just JavaScript has a function called max. You can give it a set of parameters, and it would just pick out the highest number. So that's what I did. I restructured this spread. I spreaded this array into the parameters for mathmax, and then it just gave me the highest seed ID. So that was part one. Pretty straightforward. I'm pretty happy with the result. It's readable, very much so, if I must say, and it's short. So that's why I really like functional programming. And part two was to figure out what my seed ID was. And what I did was pretty nice. So we ended up with from previous part with the seed IDs, and I just sorted those seed IDs. And then eventually, because the plane was full, that was the puzzle said the plane is full. So eventually, there should be in that list of seed IDs, and they were going up. Each seed ID was going up by one value. Then I knew there was the missing value in there, had to be my seed ID. I don't know if I can show you how it looked like, but it was basically, let's say it was like 45, seed ID 45 was I think the first, or 46. And then it was 47, 48, 49, 50, 51, and so on. So what I did in the second function here, after sorting the array from lowest to highest seed IDs, I'm doing a filter, and it's basically saying if we're not at the last seed ID, which is basically we went through the entire array, so that's just like to safeguard myself from the second half of the conditional, because here we're accessing the next element. So for the first iteration, this seed ID would be 46, and here we get the next element, which is 47. And I'm doing a +1. If we get to the last element of the array, +1 is gonna be an out of the bounds of that array. So that's where I'm safeguarding for that here. Otherwise, I could just do this. And this is basically saying, hey, is the next element in the array higher, one higher than the current element in the array? Then we do have, then our next seed is not the our seed, so just continue. And then it's going to stop and return true as soon as it finds a missing seed ID for the next seed ID. And then we capture that value, and we store it to the seed ID below my seed ID, and I just add 1 to that ID, and then I found my own seed ID, which in this case was 594. So that's how I did it for day 5. If you want to see the instructions, sorry for that, my voice is having a little bit of trouble. I'm gonna take a sip. If you want to see my instructions, have a look. I'm gonna link them in the chat. And then day 6 was actually easier than I had expected. I would expect it by around day 6 to actually do some really code intensive stuff. But day 6 was the shortest solution I had to write so far. It was really short. And let's see what the day was about. It was so we boarded the airplane, and we had to fill in. We were en route to a transit, because we took a national or like a regional flight, and then we had to take an international one. So in this first flight, in the regional one, we had to fill in a customs declaration form, and I had to help basically the entire airplane to figure out their answers to the sheet, because you had to fill in for your group as well. So your input was, let's download the input. The input was this basically. What this means is that every new line is a new different group, traveling group in that airplane. And then for each group, these were the individual answers for those people in that group. So in this case, we have the first group has 4 people in it. And these letters are question numbers. There were 26 questions going from A to Z. And these are the letters for which that person, so here the first person of the first group, answered yes for. So this person, the first person, answered yes for the question T, question Z, question I, B, Q, and so forth. And these are the answers for the second person, third, fourth, and then we have the whole group. And for the first part, our puzzle was to calculate the sums of yes questions. So let's look at here. This person answered yes for 4, 8, 11 questions. So then this would be 11. And the second person answered yes for 6 questions. So this would be 6. This would be 6 again, and this would be 5. And then you had to calculate, you had to add these up. So 11 plus 6, 6, that would be 23, plus 5, 28. So the sum of yes answers for this group was 28. And then you had to go calculate that for all the groups and add them together. I think, was it? For each group, count the number of questions to which everyone answered yes. Yeah, you had to add them together. And for me, my answer was 297. How I solved that was, let me pull up day 6, was first I split input in new lines. So then I got an array of group answers. So this would be an array element, and this would be another element. And then I used map to map that array, each group answer. And then I'm doing something tricky in here. It's not the most readable code, but what this does is, because arrays in JavaScript don't have a... Hi Lars, nice to have you here. Welcome. Because arrays in JavaScript don't have a unique method to grab if you have duplicates in the array, to discard the duplicates. I had to make use of this trick. I could either do this or import a Lodash library, a helper library, and because it does have a unique method, but I wanted to, I'm trying to not use any third-party libraries for as long as I can in this event. So I try to stick to native methods as much as possible. So what I'm doing here is I'm using a trick by what this does is for each boarding, for each answer sheet, split it into new lines. So then we're going to get an elements of answer sheets, and then you join them into one long string, and then you split that string into an array. So this is what this part here does. This here is add these strings together and then split them, and then each element is going to be a character. So this is going to be a character, this is going to be a character until the last one. So then we have an array with character elements, and then I'm adding those to a set. So you can create a set by giving it passing it an array. So I'm creating a set with that array, and a set can only have unique items in it. So by creating a set from an array, you automatically discard the duplicates, because a set cannot have more than one element, one unique element. So I'm creating a set out of those, and then I'm spreading the set again into an array, so I can use the dot length function. I could have just used dot size and not have to spread it to an array. This would have worked as well. Actually, I think, yeah, I just need to wrap it in like this. I think this would have worked. Not sure, still getting syntax error. But yeah, that's what I'm basically doing here. And I'm just counting the length of the characters, and then I have the sum for a group, and then I use reduce to calculate the sum of all of the groups, and then that's the answer for part 1. And then part 2 was there were new rules into the counting. You had to calculate the let me see. You had to calculate the questions for which all of the individuals answered yes for. So in this case, only B was answered yes by all the 4 people, and I don't know if another one, A as well. I see A, and that's about it. Yeah, B and A. All the people in the group have yes for those 2 questions, and therefore we only count those 2. So what I had to do here is again, I'm splitting the group answers into individual person answers. What I'm doing is I'm picking out the first person, and I'm splitting that string into an array. So this string is an array of characters, and then I'm filtering out. I'm going through each character, and I'm filtering it out. If it doesn't find it in any of the subsequent answers, or no, not any, all. So for T, for example, what the code does is, okay, T, is it present here? Yep. Is it present here? Yep. Is it present here? Yes as well. Okay, so T is actually T as well. Is yes for all. And then it goes to Z. Z, it doesn't find it in the second person, so is discard Z, it returns false. So this filter function only returns true for the elements, for the characters that are present in all the person's answers. And I do that by removing the first person from the array, because that's the person we're already using as a base. And then for every other person, check if the current character we're looking for includes, or the current question is included in that person's answer. If it is, then continue to the next. And whenever this returns false, then every returns false as well, because every returns true if all of the elements return true. That's basically it. And then I'm left over with the questions which all the people answered yes for. I'm doing the length on that. So then I get the groups count, and then I just count all the groups with a reduce, similar to this reduce, counting all the groups together. And then for that question I got 2,971, and for the first one it was 6,161 actually. Yeah, so that was day 2. Quick recap, maybe not that quick, 20 minutes, but yeah, let's go on with day 7. Exciting things. I've heard this one is a bit tougher. I tried not to get too many spoilers on my social media on day 7, but it involved something with treative also. So let's see. Oh, by the way, if you haven't noticed, this is a ASCII art. Each year, Advent of Code has a ASCII art that reveals itself as each day passes by, and this ASCII art starts to look like our journey. So each day we need to solve a puzzle in at a particular section in our journey. And here we started on top of the mountain and went down the mountain with a toboggan. And I think this 2 brackets are like the airport, and then this is the flight. So we were flying, and then we arrived at our transit area. So it's like an island. I think this the waves are like blue waves are like ocean. This is an island. I think that's kind of like how it looks. So I think by the end we're gonna end up with a map with from North Pole going to our tropical island resort. I think that's what the ASCII art is going to look like. All right, day 7. Let's start. Handy haversacks. The story goes, you land at the regional airport in time for your next flight. In fact, it looks like you'll even have time to grab some food. Nice. All flights are currently delayed due to issues in luggage processing. That's probably going to be where we'll need to that's where the topic where our today's puzzle is going to evolve around, fixing luggage processing issues. Due to recent aviation regulations, many rules, which is the puzzle input today, are being enforced about bags and their contents. Bags must be color-coded and must contain specific quantities of other color-coded bags. Okay, apparently nobody responsible for these regulations considered how long they would take to enforce. For example, consider the following rules. Light red bags contain 1 bright white bag, comma, 2 muted yellow bags, dot. Dark orange bags, okay. These rules specify the required contents for 9 bag types. 9 bag types, yeah, so each line is 1 bag type. In this example, every faded blue bag, faded blue in here, is empty, contains no other bags, is empty. Every vibrant plum bag, where is vibrant plum? Oh, here. Bag contains 11 bags, of which 5 are faded blue and 6 are dotted black, and so on. Okay, this seems straightforward. You have a shiny gold bag. If you wanted to carry it in at least one other bag, how many different bag colors would be valid for the outermost bag? In other words, how many colors can eventually contain at least one shiny gold bag? I see. In the above rules, the following options would be available to you. A bright white bag, which can hold your shiny gold bag directly. Oh, I see. A muted yellow bag, which can hold your shiny gold bag directly, plus some other bags. A dark orange bag, which can hold bright white and muted yellow bags, either of which could then hold your shiny gold bag. Oh, I see. And then, so because, let's see, dark orange can have bright white, so dark orange, where is dark orange? Here. Dark orange can have bright white, and bright white bags can have shiny gold bag. Therefore, dark orange can have a shiny gold bag. Okay, I see. We need to do some graphs traversal. I see where that comes in here. In this example, the number of bag colors that can eventually contain at least one shiny gold bag is 4. 4. Okay, how many bag colors can eventually contain at least one shiny gold bag? The list of rules is quite long. Make sure you get all of it. Get your puzzle input. Okay, so these are all the, what are these again? Rules. These are all the rules. Okay, yeah, these are all the rules. So dull indigo bag can have 4 dim magenta bags, 4 shiny magenta bags, 2 pale yellow, 1 plate cyan bag. All right, and then we need to find out our shiny gold bag for which bags of these. Each bag has a unique color, and which bag we can eventually put it in. Interesting. All right. let's create a new day for our puzzle solution here. New folder. Day, no, not in that one. Day 7. And we're going to save our input in this day. Lars, did you finish today's puzzle? Day 7. And then I always get to remove the new line at the end so that we have a clean input. Yeah, finished today's puzzle. How did you like it? Was it difficult? So Lars does the puzzles in ABAP, like a business programming language, I think it stands for. And it looks very interesting. I wonder if graph traversal is something that's difficult or easy in ABAP. Or maybe he solved it a different way. That's also possible. And then I'm going to copy the setup code from previous day, where we read the input file. Okay, I'm going to put our solution for part 1 in here. Okay, and as I go through the puzzle every day, I try to think out loud and kind of take you through my thinking process. If you like, I try to like explain what I'm thinking about and how I'm reasoning about things. If you find if I'm using a particular JavaScript method you want to get more explanation of, or like if you don't completely understand how something works that I'm writing about, just feel free to ask in the chat. I'll happily explain what is happening, or just take a moment to explain what this particular line does or trick, whatever. I don't mind at all, so feel free to ask. Okay. Graph traversal. I'll have to do this by hand because solved the puzzle quite fast. Had lots of trouble to get it running due to transpiler bugs. Oh yeah. So yeah, the Lars is transpiling ABAP language in JavaScript, and I think you had that in the beginning of the event as well. So the challenge seems to be fighting the transpiler, not the actual puzzle. Different challenges, yeah. All right. I'm going to have to go through the input, and then I'm going to do, let's see. Yeah. So I'm going to start at the top, bright olive bag. And what I'm going to do is I'm going to record, keep track as I go through the input. Okay, so my thought process like this. I get a bunch of input. What I will do is I will go through each line in the input, which is going to be a unique bag color. And I'm going to figure out whether the shiny gold bag can fit in that bag or any of the children bags, nested bags. So then as I go through the first line, bright olive, I record that. And then I see it can have two different types of bags, dotted white and wavy lavender. I take note of those, and then I go and search for the first one, dotted white. I go in it, and then I search for dotted white. Specification, it's here, or rule. So the rule for dotted white, it can have 4 different bags: dark teal, dull white, pale salmon, dotted plum. Okay, and then I go for the first one, and I look. I can either go for the first. So there's 2 ways you can traverse a graph with children. You can do it by going left first. So you go as deep as possible so you take for each one, you take the first one. So then you look dark teal, you look up the specification for dark teal, and then you take the first bag of dark teal, and so on. So you kind of like go, as you create a tree, you go left first, and then you go kind of like traverse to the right as you go up and down the tree. Or you can go it from top to the bottom, and then you have the first node, and then you have children nodes, and you go through all the children nodes first before you go one level deeper, and then you go to all those children and so forth. So then the code for each of those two approaches looks different. Let's see which approach I want to go on with this case. And I'm going to choose the approach that's easier to code, or at least for me, more straightforward. Um, mm, mm, mm. Do I go into dark teal bag with the code? Because then I'll eventually have to look up the dark teal rule, and then another rule, and another rule, and I have to keep track as I go. Or do I just keep track of dotted white and then go back and then keep track of wavy lavender and then go into dotted white children and then wavy lavender children and then the children of dark teal, then the white and so forth. Well, that seems more difficult to code wise. Both are difficult for me. I am not that very strong at this traversing graphs by hand. It's very data computer science. Let's say I've never worked for a big Facebook, Google, Amazon, big IT company. So I never had to actually learn this because you don't use them in your daily job. But I'll try and make them work. Okay, I think I'll go with left first traversal to the graph. And then basically as I go through the graph, as soon as I find a shiny bag anywhere, I can consider that bag can shiny gold bag. I consider that bag the parent bag that it can hold my bag. So I add, I'm going to have a variable that I'm going to keep track of how many bags can hold the bag. Okay, so let's first instantiate that variable. Let bags that can hold my bag 0. Okay. And I'm going to go through the input. Let's first split the input by new lines. Input split new lines. And then I can split each line by contain, because then on the left half we have the current bag, the parent bag, and on the right hand we have the children bags. So let's split this by space contain, and then we have wait a second. So wait, first for each new line, what do I want to calculate? Oh, I want to map it. Yeah, so I want to map each. Actually, I can just move it up top. Let's see. Yeah, I won't have to keep track of bags counts because I can just map this array into those values. So map bag rule, bag rule. I'm struggling here to type. Why am I struggling to type? Yep. Bag rule, and then bag rule, we split this one by contain. So let's let's get rid of this line. Nope, not like this. Wait. Yep. There we go. and then we have on the first half, first element of the array is going to be the bag color, and then the second element is going to be children bags. Children bags. There we go. Let's remove this here. Good. So now we have we're inside of each bag rule, and then we picked up the bag color, which is this. I'm going to split by bags contain instead, because then I can just get the actual color. Bags contain. So now we have the bag color in here, and on the right hand side we have this. So we'll have to split them by comma. I think we need to remove the dot here at the end, and we can do that by splitting by dot new line. So it's going to not be there in the beginning to begin with. So then we are going to have this, and then we split these by comma space, and we end up with the number and the color bag, from which we can extract the color using a regex. We'll have to use a regex for this. Okay, so here's what we're gonna do. Children bags. I'm still gonna say that this is children's bags. Oh, we can keep it like that actually. Children bags, and then we can have a new variable which says children bags color. Children bags color. Children bag colors. Oh, naming is hard. Okay. Split by comma space, and then don't delete it. So then we have an array with 3 wavy yellow, 1 shiny indigo. Okay, I need to do a match for each. Children bags. I'm gonna map, because we want to end up with colors. Map children bag. Children bag color, and we want to match using a regex. So I'm going to pull up the dev docs, which is my favorite document aggregator. JavaScript string method, and match. Where's match? Here. The match method retrieves the result of a matching string against a regular expression. So we'll have to regex global az. Yeah, we'll have to match the back color, which is going to be, I'm gonna pull up regex regex r. Let me try regex r now. JavaScript flags, no global. Let me have let's use this example as input test. Okay, so I can use this tool to regexr.com. If you want to have a look, let me paste it in the chat. I'm not very strong with regexes, so I always use this handy tool to help me out writing regex syntax, because it can be very cryptic at times, especially the longer ones when you get nested and nested captures and so on. So I need to capture what we know from our input is that actually our input is going to be an element. an array of these elements, and we always know it's going to start with a digit. So we can say the start of the string, if it starts with a digit, which for the shorthand for that is forward D, continued by a space, a literal space, and then starts our capture. And our capture is going to be anything. Dot stands for 0 or more elements, which is not right. Yeah, but it can be plus as well. Just stick to dot. 0 or 1 element, and then I use the star multiplier to grab as many as I can, but until I'll need to do a forward. Do I need to do a forward look ahead? Let me see. The end of the string here with the dollar sign, and then I know the input ends with bags or optional s. How do I do optional? Cheat sheet. Bag or bags. I can do that. Yeah, bag or bags. Wait a second. And then I need to capture anything in between. Yeah, so I need to do a forward look ahead. Let me look up the cheat sheet for forward look aheads. Look arounds here. Positive look ahead, negative look ahead. Non-capturing group. Maybe this is what I need. Let me think. How do I positive look ahead, negative look ahead? Let's see. Match is a group after the main expression without including it in the result. Matching group after the main expression without including the result. Wait, I'm not going to use look aheads. What I can do is I can use a different modifier. Instead of star, wait, a cheat sheet quantifier. Yeah, so instead of star, which is, wait, there's no star here. Oh, here is star. 0 or more. I'm going to use, no, that's not going to work. Oh, here, yeah, match as few as possible. That's what I need. So I need to add a question mark in here, which is going to match as few as possible. Hopefully. Let's see. So starts with, okay, and I need to say in between here is going to be capture, well, any word letter. There's a shortcut for that as well. Cheat sheet, character anchors, escaped. I have a different regex helper. I know it's in there. regex101.com. Common general tokens, anchors, group. Where is it? Character classes. Oh wait, JavaScript. Common tokens. Here. A word boundary, non-word boundary. A digit, any word character. Here. /W. That's what I'm looking for. So any word, and let's have this capturing group inside. Any word followed by bag or bags at the end. Still, let me add a flag for global, I think, or it doesn't matter. Why isn't it working? paste it in here. So something's not working. I need to catch. Oh, it is working. Awesome. Dim 10. Let's use the global modifier, multi-line, not global, and add more test cases. Let's add these all. Do I need to use global? Seems to work. Group 1 dotted line, drab white, bright beige. Okay, so we have a regex that captures the back color from the back rule. So let's put it in here. And then I'll return an array with the first element, I think. What does it return? Yeah, the first element is the full string, so we don't need that. We need the second element, which is our first caption group, I think. Let's see, return value. Depends on the presence of the global G or not. We're not using a global flag, so therefore the first complete match and its related caption groups are returned. Additional properties. I know I can do a named capture. What's a named capture in JavaScript? Named capture. Named capture. JS. Let me see. Pop out. There we go. Sorry, I was just getting rid of spam in the chat. I'll just stick to 0. I think we're good here. And then I forgot what named captures are. The syntax kind of like question mark equals or something. But I'm just going to do this. Get it the second element of the array. That should be good. So we have the children bag colors, and then what we want to do. Oh, we're not done yet. So we have the colors, and then we need to, for each color, go into for that color, figure out. Wait, let's start with the parent color. If children bag colors includes our bag. Oh, wait. Which is shiny gold. Our back color is shiny gold. If it includes, then we kind of like we need to return. Actually, we can do a filter. Then we only have the rules that we need in there. Let's see. So we are at the parent bag, outermost bag. If one of the children bags is shiny gold, which is ours, then we don't need to traverse the graph deeper. It can already hold our bag. So we can stop there. Otherwise, it needs to go a level deeper. And I'm going to use a recursive function. I'm going to have to create a function here that's going to traverse the graph, because we're going to have to use the same code a bunch of different times. Each time we go a level deeper, it's actually all the same code. So we avoid repeating ourselves by having a recursive function that calls itself and then stops as soon as the end. There's no children bags anymore until we find an empty bag. So that's what the function is going to look like. And I'm going to call it traverse bag rules. And it's going to have an input. The first parameter is going to be the bag rule. Or I can say bag color. And the second parameter is going to be it's going to be the graph. But I'm thinking whether whether I should pass, yeah, I'm gonna pass the let me think, because in here we have an individual bag rule, and then I pass it a bag color. So let's say for this one I pass it wait, I'm just gonna go to my here. So I pass it dim 10, which I then need to look for the dim 10 bag rule, and I don't have, so I'll need to pass it entire array. Okay. Therefore, I'll need to extract it to a different. Oh, the alarm's going. Just a second, guys. I'm gonna be right back. Someone is at the door. And I'm back. Sorry for the hold up, guys. Thanks for waiting, guys and girls, I must say. Yeah, I had a package delivered, so I had to open up for the mailman. All right, back to our puzzle. Oh, and also I'm living 2 stairs on the second floor, so third floor. So I had to run downstairs and run back up. So that's why I'm a bit out of breath. All right. So we have, I'm going to extract this into a different function. Wait a second. I'm going to make my life a little bit easier. I disabled the arrow keys this weekend because I'm using a couple of rules to stay on the home row and to not have to use my, wait, where's the, because okay, I still have to get used to it. So then I just, for the stream, I just disable them really quick. Here, I'm gonna open the config file. cd config. What do we have in here? Oh yeah, so I need to open carabiner edn. I use carabiner to remap keys on my keyboard, and in order to really get to learn the movement, moving my cursor, in with the home row. I just disable the arrow keys, but I'm gonna undo that now because I'll be faster in the stream. Wait, I just wrong go. Yeah, it doesn't matter. Okay, so yeah, arrow keys work perfect. All right, so back to our puzzle. So I'm going to extract this into a variable because we're not gonna have to pass it on, and then I'll just say here. Actually, let me copy this one here because and in here I'm gonna say back rules. Back rules. Okay, and then great. I think that's it. Checking the chat, all good. All right. And then because I will use this the back rules to pass it into the function because it's gonna need the function. Well, I don't need to pass it. It's just available to it. Da, da, da. Move line up. Nope. There. It doesn't matter because they're scoped anyway. Just so I know. Okay. Traversing function. Ooh, right. So get the back color in here, and I need to find for that back color. I need to find its rule. So then I just say wouldn't it be easier if I just pass the back color and back rule as a parameter and look for the rule outside? Well, it doesn't matter much. No, not really. Const back rule. Bags rules. Find bag rule. Bag rule starts with the back color. Does it? Yeah, it starts with the back color. Then we found the bag rule. Okay. I think this should be correct. Let me double check this. We get an array of bag rules, and then if it starts with the bag color, then we found our bag rule. So therefore, we do a find, and I think find does what I think it does. Let's verify that. Array find. Where's the F? Here. Find returns the value of the first element in the provided array. That returns true. Okay, so then we found the back rule, and then we'll need to do this same code in here that grabs the children bags. So we're just gonna copy that. We already have the back color, so we don't need that. And then we grab the back colors, and then we actually need to figure out if it returned, if one of the colors includes shiny gold, then we need to stop traversing the graph. So we need to return here. Otherwise, false, or go until or just like call yourself. Yep, with We have, for each of these, the traf needs to traverse. So I'm not going to do that in a one-liner. I'm going to put this in an if, which is kind of like going to be, whenever you have recursive functions, you need to make sure you have a stop condition uh, to avoid recursing for infinitely. So this is going to be one of our stop conditions. So if we found the shiny gold color of the bag in any of the children bags, then we just return. Let's return true, and then and we can rename this function to be well. We can rename it later on after it's more clear what it does. I'm still not 100% sure what I'm going to do with this function. But and then another one, if you find an empty bag, we kind of like reach the lowermost node in the graph because that bag doesn't have any more children, so we kind of like stop there. Therefore, let's see what an empty bag looks like here. Contains no other bags. So I think if we need to find for this no other bags. So then we split the bag colors in here. What we're gonna have is just one element which says no other bags. So if children bag colors well, I'm just gonna do this includes no other bags, then we have to stop traversing the graph deeper because there's no more nodes, and therefore we return false. I don't think I got the stop condition, or at least I want to find out if this function returns true. Yeah, I'll figure that in a bit. So we have our stop conditions in here, and otherwise it's just going to look inside those children as well. So traverse return traverse bag rules, but it needs to do that for each one of them. Children bag colors for each. Return. Let's see. I'm sure I approached this wrong, but let me think. So back to where we started. We pass in a child color. Well, we pass in a color, and then we find the rule for that color. We found the children of that bag color, and then if the children is no other bags, then we reach the end of the graphic, we return false. And if we find shiny gold, then we return true. And then we return true if any sum, I think we also need to return true whenever any of the children bags return true. Yeah, so let's do that. And I think sum or any, some, I think some, at least one element. Yep, some, good. And then return, wait, children bag colors, children bag color, traverse bag rules, children bag color. I think this is what I'm looking for. So if my intuition is right, I'm gonna have to run this first to see if it works as I expected. But what we're doing here is, if any of the children return true for the shiny gold color, or then any of those children return true, or those children and so forth, then return true, because then we find our eventual child bag that can hold the shiny gold. Therefore we can just stop looking, because we know the parent bag can hold our bag eventually. But how, I'm just thinking out loud now, how the graph is going to traverse, if it's going to go left to right or top to bottom. On the first input we get a color, let's see, let's go top. Okay, so dotted white goes in here, dotted white, and then it grabs the we can say, we can start the parent. So the parent is bright olive, and then it runs for each color, it runs this function. So for the first children color, dotted white, it calls traverse bag rules, and then so it goes in there. And then for the first children, okay, so it goes from left to right. It traverses the graph depth first instead of breadth first, and then so yeah, I mean, it depends on the input whether one method is faster than the other, but yeah, I'm just gonna stick with this because it's what I came up with intuitively. And then I'll need to refactor here into using the function that we here up top. Let's see. I think I can just say, can't I just say filter traverse bag rules? Yeah, can't I just pass this function to filter, and then console log answer part 1. Wonder if this is gonna work. Bags that can hold my bag dot length. So we have the number of bags. Let's run it. I'm kind of scared that I'm gonna run it on an infinite loop here, which I always am when I write recursive functions, but let's see. Split of undefined. Yeah, oh sure, I'm missing here something. Bag rule, bag color. Oh, I see. Wait, I'm gonna rewind this a little bit. So bag rule, it passes in bag rule. Well, here it passes in bag color. Okay. I think I can do it bag rule and just paste this here up top. It's gonna be bag rule. Wait a second. No, that's not a good approach. I need to keep this out, I think. So this traversal function takes in a back color, and then for that color goes all the way down to the takes the entire tree. So if I just pass in the back color of the top bag, it's gonna do the work. So we have the bag rule here. We grab the bag color. We don't need the children bag because we do that in the function as well. Although we could pass it the children bag in the function, and then it won't have to make use of a global variable. But we'll figure that out later. Let's do it like this for now. Children bag. So then I can get rid of this, and I can get rid of this stuff as well. So then I just say return traverse bag rules for that bag color. Okay, this should work. Let me console log this first. Sort part bags that can hold my bag. All right. Okay, let's run it, see what's going on. Again, split of undefined. Oh yeah, because what am I doing here? Bag rule. Oh, so it didn't find a bag rule for a bag. Interesting. Starts with bag rule. Just let me console log the bag color and bag rule, and find out. So for wavy brown, the rule is wavy brown bags contain no other bags. Okay, no other bags. And then needs to find the rule. Oh, and it doesn't find the rule because no other bags have no rule. So I need to put this I need to put this at the top here before I do the split. Like this. If children call bag colors, no, I'm gonna do it like this. If bag rule no, I need to keep this one. So I'm gonna move it up top. If I actually find the shortcut, no. There we go. I see. So we have this up top, and then we have children bag. So I'm gonna do children bag. Wait, where is it complaining? It's complaining at this bags contain. What does bags contain? Okay. Bags contain no other bags. Bag rule. Oh, wait a second. I'm a bit lost now. Let's go back. Okay. So I'm logging the bag rule here, wavy brown. The bag color, I mean. And bag rule here, wavy brown bags contain other bags. And then I try to split the bag rule by bags contain. Bags contain. But it says cannot read property split of undefined. So bag rule is undefined because, oh yeah, because no other bags is. All right. I'll need to, I'm going to do it like this. If bag color is equal to no other bags, then we reach the end. And I'm gonna do this, put this all the way at the top. There we go. I think that should fix this this particular issue. Maybe not. No other bags, return false. Bag rule. No, still not working. Let's add a console log back in there, see what's wrong. Back color is undefined. So in the previous round we had wavy brown, and then contain no other bags, and then so the children bag colors is this split. We have one element, and then map. So children bag colors is okay. I'm gonna do this differently. Instead of doing it here, I'm gonna do it here, and I'm gonna say if bag rule ends with no other bags, then so somewhere my stop condition isn't functioning correctly. So we're trying to split a color which is undefined. Okay, this seems to work, and we get a result. Although I'm pretty sure this is not correct. Luck would be too much on our side to have our first correct answer on the first try. I can. Okay, let's just guess. Let's just verify if it's correct or not, and then we can debug later. I wanted to see if the code makes sense, but let's just go ahead. Oh, it is the right answer. No way. I was not expecting that. Writing a traversal, yeah, writing a graph traversal for correctly in the one go. Awesome. Then we can just go to part 2. Typical example of it works, but I have no idea why. I mean, little dog meme in a lab, you know. Yeah, but I want to understand a bit better how this works, though. So I have I pass in I have a function, of course, a function, and I pass in a color, and then it grabs the bag rule, and then if we figure out that that bag is empty, then we can return false because there's no other bags. If we do find other bags, we grab them, we capture the colors, and then if we find shiny gold, we return true for that particular depth of the tree. So we don't need to go deeper. We can already assert it's true. And then because we do a depth first search, then it's going to it's not going to continue, or is it? Return true. Sum. Yeah, sum is going to say, okay, we don't need to continue for all the nodes. We already found one that's true, so return this function, and then we filter. Yeah. And it ran quite fast. My solution for part 1 took 7 minutes to run. Oh, I guess ABAP is not that memory efficient or efficient of a language at all. I can measure how fast it takes to run. Just put it here, console time perf, and then console time end perf. 1 second. Not bad at all. Yeah. 7 minutes, different skill. Did you get it right the first time, Lars? Because then it's a lot of waiting if you have to wait 7 minutes if to find out if your answer is correct or not. Yeah, depending on how many trials and errors. I did a few tricks. Okay, some optimizations to get it running faster. Okay, let's go to the second part. Cool stuff. Continue to part two. How far in are we? 1 hour, 20 minutes. I planned the stream for 1.5 hours. We have 8 minutes left. I don't think we're gonna solve the second part in 8 minutes, so I'm gonna definitely run a bit over that. But hopefully not longer than 2 hours. And then from tomorrow on, it should be 1.5 hours because we took 20 minutes on Monday today to recap the weekend, but we won't have that tomorrow. So hoping days 8, 9, and 10 I'm going to be able to stick with within a 1.5 hours to finding the solutions. Oh, yeah, it was correct the first time, but took an hour to get it running at all. Oh, an hour. That's a long time. All right, part two. It's getting pretty expensive to fly these days, not because of ticket prices, but because of the ridiculous number of bags you need to buy. Consider again your shiny gold bag and the rules from the above example. Faded blue bags contain 0 other bags. Dotted black bags contain 0 other bags. Vibrant plum bags contain 11 other bags. 5 faded blue and 6 dotted black. Okay. So a single shiny gold bag must contain dark olive bag, and the 7 bags within it. One dark olive bag. Wait, so a single shiny gold bag must contain 1 dark olive bag and the bags within it, and then 2 vibrant plum. Why 2 vibrant plum bags? Because the 11 bags within each of those. Okay, I don't understand this at all. I'm gonna reread. A single shiny gold bag must contain 1 dark olive bag. Is this like a new rule or something? Or it's getting pretty, because of the ticket. Consider again your shiny gold bag and the rules from the above example. Oh, it's traversing the graph from the other way around. It goes from the children to the parent. So it goes from bottom up. So must contain 1 dark olive bag. Why? Because the dark olive bag, the shiny gold bag, must contain 1 dark olive bag and 7 odd bags within it, plus 2 vibrant plum bags. And the 11 bags within each of those. Lars says, check the rules above. Yeah, let me reread this question. It's getting pretty expensive to fly these days, not because of ticket price, but because of the ridiculous number of bags you need to buy. Consider again your shiny gold bag and the rules from the above example. Rules from above example on here. Okay, shiny gold bag. Shiny gold bag. So in order to carry shiny gold bag, I need to, where does it begin? Faded blue, dotted black, faded blue. Oh, I think the rules are just in here. Okay. Yeah, vibrant plum can have 5 and 6. Yeah, the rules are in here as well though. 5 and 6. Faded blue, no bags. Dotted black, no bags. Faded blue, dotted black. So a single shiny gold bag must contain 1 dark olive bag. Oh, here, shiny gold contains 1 dark olive and 2 vibrant plum. Oh, I see. Okay, so the bag we carry already has bags inside of it. I get it. Must contain 1 dark olive bag and 7 other bags within it, plus 2 vibrant plum bags and 11 bags within each of those. And then we reach the end because those bags don't have any bags, are empty. So the formula goes 1, which is the shiny wait, 1 plus 1 times 7, yeah, plus 2. Oh yeah, the actual bags and shiny gold bag, plus 2 times 11. Let's see how the formula goes again. The parent bag, that's 1, the shiny gold bag. Then inside the shiny gold bag, we find 1 dark olive and 2 vibrant plum bags. Okay, so that's 3 bags, but that's 2. I don't know why that's 2. 1 times 7, so the dark olive bag has 7 bags, of which are empty, so we can just say 7. So we have 1 dark olive, so 1 times 7. Okay, and then we add 2, and then wait, I don't know what the 2 is for, because we have 2 vibrant plum bags, and each vibrant plum bag has 11 other bags, which in return are empty, so we can just consider those 11. 2 times 11, I don't know what 2 is for. Is this a mistake? No. 2 times 11 is 22, plus 7, plus 3 is 30. Wait, 22 times plus 7 is 29, plus 3 is 32. So, yeah, the formula is correct with the result. What is the 2 for? Don't get it. We have 1 shiny gold bag, that's 1. We get 3 more bags, so that's plus 3. Oh, wait. Oh, I see. We calculate the bags inside the bag, but then we also calculate. No, because the question is, it must contain. Okay, so the shiny bag itself, we don't count it. We don't count it. We say we have 1 bag of dark olive, and that bag has 7 other bags. And then we have 2 bags of vibrant plum, and those bags have each, or like in total, so 2 times 11. Yeah, 11. Okay, now understand it. So if we have 3 bags, we're gonna have 3 parts like this. The first one is the bag count, and the second one is how many bags are within that. Okay, I kind of get the formula now. We'll need to code this in program. 2 is number vibrant in shiny gold. Yeah, awesome. Thanks for giving me that hint, Lars. All right, so another example. Let's read this part first. Of course, the actual rules have a small chance of going several levels deeper than this example. Be sure to count all of the bags, even if the nesting becomes topologically impractical. So physics aside, how many individual bags are required inside your single shiny gold bag? So in this example input, a single shiny gold bag must contain 126 other bags because there's a lot of nesting. Or let's see how the nesting goes. 2 dark red bags, 2 dark orange, 2 dark yellow, 2 dark green, 2 dark blue. So it's kind of like 2 to the power of 8 or so, to the power of 8, which, yeah. Okay, we have the same input. So we need to figure out our shiny gold bag. Let's find it. Shiny gold bag rule. Here it is. So we're gonna start here, and then we're gonna go into wavy gold bags, and we have 3. So we're gonna have to do 3 plus 3 times however wavy gold bags 1 wavy gold bag needs to have. So we kind of have the same traversal rule again, but instead of returning true or false, we need to return kind of like the amount of children bags. So let's copy this logic from up top, and we're gonna call this function traverse bag rules. Yeah. But what I would like to do is, yeah, I'm just gonna rename the functions. I can't come up with a better name than this. Traverse back rules for part 1, just part 1, yeah. And traverse back rules part 2. And so we're gonna get in a color. We're gonna get in a color, and then, and actually we can just say traverse back rules part 2 shiny gold. So the first time it's gonna pass in shiny gold, and then we need to find the bag rule for that color. And if the bag rule ends with no other bags, then we need to return 0, because that bag doesn't have any bags inside it. And if we do find other bags, then we split the string, and then we get the children bags, and then we extract the colors, and then we don't need this anymore because our parent is going to be parent bag is going to be shiny gold, so we won't find shiny gold anywhere in the children. And here we need to say, okay, for each bag color we need to return the sum. So we can say reduce, not sure if this is going to work, 0 children bag color sum of bags. Sum of bags needs to be sum of bags plus the children. So I'm using traversal here because I have to do it anyway, but I'm not using the actual formula they have though, because for this I would need to know how many children 1 times. Maybe I do need to use it. Let me see. Reduce. So shiny gold has, oh, maybe I do need to use it. So shiny gold has 3 wavy gold bags. So it needs to be the amount of bags for this the current bag. So that's, I guess, children bag colors dot length plus plus children bag colors times whatever their children have, I think. Let's see if I get this right. I'm gonna make it a bit more readable here. Return it's correct. No. Yep. Okay, that's a bit more readable here. So we have the children bag colors. So we have 3 in our case. Shiny gold has 3 wave bags, so 3 of them. No, that's different colors though. We need to extract the number. We don't do anything with the number, do we? No, we get the bag colors. Okay. So we have the bag colors in here. Let me think. Children bag colors. Let me do it like this. Children bag colors. what I want to do is I'm gonna have this array, or no wait, this, because I go through that array. So for each item in the array, I'm gonna, for each bag color rule of, no, that's not correct. Children bag rule. No, it's not a bag rule, is it? It's a children bag. It's this. What do we name this? 3 wavy gold bags. Bag. Yeah, children bag specification. Children bag specification, and then we split it. Children bag specifications. And so we go through those, and then we have children bag specification, and then we want to extract the number and the color. So we can, I know we can do match. Can kind of like copy what we have over here, and then we can create 2 variables. And we're gonna name them children bag specification, number of bags, and bag color, because that's what we're gonna end up with. And then in here I need to capture, let's go back to our regex debugger, and I'm gonna capture the number as well. So let's wrap this in parentheses, and we should get 2 matches: the number, the color, the number, the color, the number, the color. Yeah, looks good. So I'll just wrap these in parentheses then, and then we're gonna end up with an extra item in the array. So in here, okay, should be good. So what we do is we return these number of bags plus however many bags those children have. So that's what we do here. And we pass the children bag color, and then we go again, next iteration. This, I'm pretty confident about this. And it's gonna return a number. So we can just log the answer in here. Console log answer part 2. Let's see if this crashes. It doesn't crash in infinite loop, but it does crash on a syntax specific. Object null is not iterable. Children back specification, because I don't split it. Wait a second. Specifications, back contain. Oh, I need to get rid of this. Yep. Start again. Children bag color is not defined. Oh, here. Yep. We get a string 030, so that ain't right. Actually, let me rename this the children bag color, because we already have bag color defined in the upper scope. So this is a bit more less confusing. And then we have, okay, so let's run this again. We end up with 030. Why do we end up with 030? Because sum of bags, we start with 0, so that's an integer. Somewhere in this addition, we add, there's a string, which messes up our calculation. So we need to find out number of bags. Oh, I see. I think here the capture is a string. So we need to cast this to an integer. 3. No, that's not right. That's not right. We need to get a huge number. Okay. Let's see what's not working here. Sum of bags 0, and then number of bags 3. So then we have 3 plus 3 times whatever is in here. So apparently this returns 0 because we end up with 3. So let's see what it does on the next iteration. We have wavy gold bags. Wavy gold bags. Okay, so on the next iteration we have this rule, wavy gold bags. So then we have wavy gold in here, we have the rule in here. If it ends with no other bags, does it? No, it doesn't. So we don't return, we continue. And then we split the rule and we grab the children bags, which is this. 2 muted tomato and 5 posh tomato. And so, and then we split that, children bag. Yeah, specifications, we split it, so we get an array of 2 elements. And then, an array of 2 elements. And then for each element, yeah, that's good. For each element, we grab the number of bags. So in this first iteration, it's going to be 2 and muted tomato. It's going to be the bag color. So we say 0 plus 2 is 2 plus 2 times whatever that returns. Oh, wait a second. I'm calling a different function here. That's a silly mistake. Okay, so I'm still calling the traversal from the first part. Yeah, this looks good. Okay, let's give it a try. I think I have good hopes. I mean, if the first one worked on a first try for the first part, we might have our lucky day. Yes, we did it. Thanks for sticking with me for 1 hour, 45 minutes. I mean, that's not too bad. We went 15 minutes over the planned time of 1.5 hours, and we used up 20 minutes to recap the weekend. So we're actually 5 minutes before our schedule. Awesome. We got our 14th star. 7th day is done. I see the ASCII art for the day 8 is kind of like another path as well. So I think we boarded the second airplane. So most likely tomorrow's puzzle is going to involve around solving another crisis on the second airplane. I'm gonna add this I'm gonna commit this solution and push it to the repository so you can have a look as well if you're curious to what we programmed today. And it should be in here. There it is. Let me link to it in the chat. Yeah, and yeah, that's about it. I'm gonna wrap it up. Thanks for joining in another exciting day. Hope to see you tomorrow at 10 a.m. Central European time, same time as today. So make sure you have the right time in your time zone, wherever you're at, the part of the world. Thanks very much for watching today, and I hope to see you tomorrow. If you want to stay in touch with me, you can find me on Twitter, underscore maximization, or no, maximization underscore. No, that's my Twitch, underscore. Here I am. Yeah. Add me on there if you want to stay in chat, send me a message if you want to talk about Advent of Code or just JavaScript in general. feel free to send me a message. My DMs are open. Thank you for joining today, and I'll see you tomorrow. Bye bye.